Hi there, this is Professor Eckhausen. I'm going to talk today about identifying the greatest common factor of a polynomial and factoring trinomials. We're only going to do in this video leading coefficients of 1, and then in the second part we will talk about leading coefficients that aren't 1. But first we need to start with identifying what a greatest common factor is. So we're going to start with numbers just as a review, and then we're going to do it with things that have variables in them. All right, so what even is a factor? A factor is the building block of multiplication. That's the easiest way to think about it. The building block, or the building blocks of multiplication. Okay, so like for 6, we would have 1 times 6 equals 6, or we would have 2 times 3 equals 6. Okay, so those are factors. Now, what is a prime factor? A prime factor means we work all the way down to the prime numbers. So 1 times 6 would not be the prime factorization because 6 is not a prime number. So a prime number means it's been divided all the way down until it can't be divided by anything but itself and 1. All right, so the prime factorization of 72, I usually use the tree method is how I think of it. So there's lots of ways to think of it, but it looks like this. You just make a little branching. So we're branching into 2 sections. It's kind of like a family tree. And so 72, just choose any 2 numbers that give you 72 except for 1 and 72. That won't help you. It'll be a waste of time. So I think 8 and 9. 8 times 9 is 72. Now, are those prime? They are not. So think of a way to divide those again. So 8 is 4 times 2. 2 is prime. So I'm going to put a circle around it, and I'm done with that. And then 4 needs to go a little farther, and it is 2 times 2. So 2's are prime, so I'm going to circle those. All right, so everything that's circled means I've worked it down to be all the way down to its prime. So 9 is, I want to do purple. 9 is 3 times 3. 3's are prime. Right, so our prime factorization is 2 times 2 times 2 times 3 times 3. Okay, so that's the expanded version. If you want to write it in exponential form, which is way more user-friendly, you don't have to write so much, this part is 2 cubed, and this part is 3 squared. Okay. So that's prime factorization. You need to know your prime numbers, at least the first few. So make sure you know that the first few primes, let's go over here and write this. The first few primes are 2, 3, 4 is not prime, 5, 6 is not prime, 7, 8 and 9 and 10 are not prime, but 11 is, and 13, that's probably good enough for now. Okay, so know that those are your first few prime numbers. Okay, so what is the greatest common factor, GCF? So let's write this. This is a fairly long definition, so make sure you've got this. The largest number that divides evenly into 2 or more. If you're doing more than 2 other numbers. In other words, it is the largest factor they have in common. Okay, I often try to help translate these definitions into English that sounds a little bit, I don't know, nicer. The largest factor they have in common. All right, so find the greatest common factor of 24 and 72. I'm going to give you a technique that will work for numbers and it will work for variables. So you may not need it if you look at this. You may know what the GCF is if you already know how to do that, but this technique is useful for all algebra. So I'm going to show you how to do this. All right, 72 we already have. We did it right up above. But 24 we do not, so let's do 24. So 24, I choose 4 and 6. You may choose something else. It doesn't matter what you start with. Everybody should end in the same place. 4 is 2 times 2, and 6 is 2 times 3. So if we were going to circle them, every single one of these is prime. And our prime factorization is 2 times 2 times 2 times 3, or 2 cubed times 3. All right, so now let's look at how we do this. So the factors of 24 are 2 times 2 times 2 times 3, and 72, let's go look at what it was. It was 2 times 2 times 2 times 3 times 3. So look at that. We've got these two in common, these two in common, these two in common, and these two in common. So that is our GCF. All right, so our GCF is, greatest common factor is going to be 2 times 2 times 2 times 3, which is 24. 24 goes into 72, so that's how that works. So I want you to notice here that if we did this a little different way, I'm going to redo it. I'm going to say 24 is 2 cubed times 3 to the 1, and 72 is 2 cubed times 3 to the 2. What you want to do is you want to go look for the 2's and find the exponent that is smallest. Well, they're both 3, so we would get 2 cubed. Then go find the next one, 3's, and find the exponent that is smallest, and that is 3 to the 1. And that would give us 24. Okay, so that is the technique. Why is it the smallest? We'll take a look here, right? It can't be the bigger one because it doesn't have anything in common. So we're talking about common factors. Okay, so all the factors that they share is going to be the greatest common factor. All right, so now we're going to do the same thing with GCF of x squared. So we've got x squared, and we've got x to the fifth. X to the fifth. All right, so I'm going to write this the long way so that you can see what I'm doing, and then it works the same way. So x times x, and then x to the fifth is x times x times x times x times x. Which ones do they have in common? Well, this one and this one. That is x squared. So all we really have to do, instead of writing this all out, is look at these two and say, they both are an x. What is the smallest exponent? That is x squared. So the GCF of these two is x squared, greatest common factor. Okay, next we're going to look at finding the greatest common factor when a number is combined with the variables. The variables are actually more straightforward because you just have to look at the smallest. So the greatest common factor of b cubed and b to the fourth is going to be b cubed. Right? So we're done with that. That's all we have to think about with that. 15 and 25, hopefully you see that the greatest common factor of 15 and 25 is 5. But if not, let's think about that. 15 is 3 times 5, and 25 is 5 times 5. And they only share this 1 5 right here. Okay, so it follows the same rule, and I'll show you how. 15 is 3 to the 1 times 5 to the 1. And 25 is 3 to the nothing, there is no 3 there, times 5 to the 2. And this one right here is terrible, so I'm going to rewrite it there. All right, so now if you think about it that way, the 3 to the 0 is the smallest because there is no 3 in that one. And the 5 to the 1 is the smallest. So the rule still works, it's just kind of weird. 3 to the 0, so anything to the 0 power is just 1. Try it on your calculator, you'll just get 1. So our greatest common factor is just 5. So the GCF overall is 5b cubed. All right. So moving on from there, let's try the next one. All right, so let's try these separately. So I'm going to write them down one at a time. So 72 we already did, and it was 2 cubed times 3 squared, and then we've got c to the fourth d squared. And then we've got 27 CD cubed. So we've got 27 is going to be 3 times 3 times 3. So there is no 2. So we've got 2 to the 0 times 3 times 3 times 3, 3 cubed, times c cubed times d to the 1, because if there's nothing there, it's a 1. All right, and I should probably rephrase that. If there's no exponent, you assume that it's a 1. If there's no 2 at all in 27, it's 2 to the 0, because remember, 2 to the 0 is just 1. All right, so let's go looking for the thing that the smallest exponent on every single one and circle it. So 2 to the 0, which means there's not going to be a 2 in the greatest common factor. And then 3 squared, that's the smallest exponent on 3, and that's for the smallest exponent on c. Well, we've got a 4 and a 3, so c cubed. And the smallest exponent on d is 1. So there you go. Now, if you want to do this the long way, you can, if it helps you to understand it. 2 cubed is 2 times 2 times 2. 3 squared is 3 times 3. And then we've got c times c times c times c, and then d times d. So you can do this if you want. It will get very tedious at some point. So we've got 3 times 3 times 3, but no 2's. And then c times c times c, and then d. I'm trying to line them up a little bit. All right, so we've got these 3's and these 3's are common between the two. And then c, c, and c, and then 1d. All right, so let's put that back together. We've got 2 3's in common, so 3 squared. C to the 3rd and d to the 1. So we will rewrite this as 9c cubed d. Okay, so which is exactly what we got here. Here's our 9, here's our c cubed, and here's our d. Either way you want to do it, you can write it out the long way, or you can do the shortcut method using the exponent rules. If you don't understand the exponent rules, I recommend that you use this method over here until you understand it better. All right, so factoring polynomials. My house is shaking because it's thundering so hard. All right, so factoring polynomials. The first step in factoring a polynomial is always to do what we just did, factor out the greatest common factor. We're doing the distributive property backwards. The trinomials we were working with are usually quadratics of this form right here. ax squared plus bx plus c. Get used to that form. We see it all the time. That's just the general form of a quadratic. All right, so doing this forwards, we would have distributed something, right? So the x times the y and then the x times the z gives us xy plus xz. Now we're taking it and factoring that x back out. We're looking for this x that can come out to the front so that if we multiplied it, we would get back to this, right? So be able to think backward and forward with all of this. So what you want to do is you want to find the greatest common factor of both of those, just like we were just doing, except now we're going to factor it out. Okay, so what is the greatest common factor of 12 and 15? Pause the video and think about it. All right, hopefully you figured out that 12 and 15, the largest number that they share is a 3. All right, what is the greatest common factor of x to the 4th and x squared? Well, we just learned how to do that, and that is the smaller exponent of the two, and that is x squared. All right, so here's where it gets a little tricky for some people. So, and that is fine, this just takes practice. What you want to think about is what would I have to multiply 3x squared by to get 12x to the 4th? In other words, we're pulling 3x squared out. What are we left with? Two different ways to think about it. Pull out 3x squared. From here, what are we left with? Well, let's see. 3 times what is 12? That would be 4. X squared times what is x to the 4th? That would be x squared. Okay, so I made a mess. Let's try to fix that. All right, so now that's the first one. And we're going to double check this just to make sure we got it. Now we've got 15x squared. If we pulled a 3x squared out, what would we be left with right there? Oh, that's really a mess. What would we be left with right there? All right, so pull a 3 out of 15 and you're left with 5. In other words, 3 times 5 is 15. Pull an x squared of x out of x squared, you're left with a 1, basically. So we don't have to write anything. In other words, if we multiplied 5 times 3x squared, would we get 15x squared? Yes, we would. So let's check the other one. If we multiplied 4x squared by 3x squared, would we get 12x to the 4th? 3 times 4 is 12, x squared times x squared is x to the 4th. Yes, so we are done. And that's how you do it. So I'm going to rewrite this so it's not such a mess. So we get 3x squared times 4x squared plus 5. And that's your factored answer. Now, if it said distribute or multiply that, you would end up back with that again. Okay, so this is multiplication and division, backwards and forwards. All right, factoring is just dividing. All right, so pause the video and give this one a try. See what you can do with it. Okay, so hopefully you gave this a try. And what you want to think about is what is the greatest common factor of 6, 27, and 30? So first I start with 6, and I think, does 6 go into 27? No, it doesn't. It goes into 30, but it doesn't go into 27. So let's think of a factor of 6, the biggest one. So it's 2 times 3. Let's try 3. So 3 goes into 6, 3 goes into 27, 3 goes into 30. So that's my quick way of doing it, but you can still do it the way I showed you with a factor tree, lining it all up and finding the factors. That will be your no-fail method, okay? All right, so we've got the 6, the 27, and the 30. We pull out a 3. All right, so now we've got x to the 4th, x squared, and x to the 1. Which one is the smallest? Which one is the smallest exponent? Well, that one is the x to the 1. So I get x to the 1, or just x, and you can put to the 1 if you want to while you're working on it. And then we've got y cubed, y squared, and y to the 1. Which one is the smallest exponent? Hopefully you see that's y to the 1. All right, so now we got to think about these one at a time. So let's go look at what would happen if we pulled 3xy out of 6x to the 4th y cubed. What are we left with? Well, what times 3 is 6? That would be a 2. What times x to the 1 is x to the 4th? That would be x cubed. And what times y to the 1 would be y to the 3rd? That would be y squared. Use your exponent rules. You're dividing, so you're just going to subtract the exponents. So 4 minus 1 is 3. 3 minus 1 is 2. So that's how I'm doing it quickly in my head without having to draw it all out. Okay. So you can keep those ones there if you want to. So now let's try this with the 27. So take 3 out of 27, what are we left with? In other words, 3 times what is 27, and that would be 9. All right, we take an x to the 1 out of x squared. 2 minus 1 is 1, so we are left with x. We take y to the 1 out of y squared, and we're left with y. 9xy. All right, the next one is 30xy, and we're going to see what happens when we take 3xy out of 30xy. This is the one that usually fools people the most, so I want you to pause the video and think about it. All right, 30 divided by 3, or how many times does 3 go into 30? That would be 10. Now, how many times does x to the 1 go into x to the 1? 1. So 10 times 1, if you really want to think of it that way. Y to the 1 goes into the y to the 1 once, so 10 times 1 times 1. We do not need those ones, right? So you don't need to multiply by anything to get x. You don't need to multiply y by anything to get y. Just 1. So when we pull it out, we're left with 10, and that's it. All right, so that is generally the trickiest ones is when we first start this, is when we're pulling out something that's the same. So there's our final answer, and I would answer this without the ones because that's not considered simplified. It is now considered simplified without the ones. All right, so now we're going to look at factoring a trinomial with a leading coefficient of 1. Always, always, always start by factoring out the GCF if there is one. All right, so a reminder that factoring is just undistributing. So let's look at distributing. So if we were going to distribute this, we would do it like this. X times x is x squared. Let's see, outside. We'll do the outside next. Minus 2x. And then we've got plus 5x, and then we've got 5 times negative 2, negative 10. All right, so remember, you can also do this with the box method. You can say x and positive 5 and x and negative 2. So this is also called the area model. So x times x is x squared, and 5 times x is 5x, and negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And then don't forget that these two generally will go together and add together, just like we're getting ready to do right now. So I've got x squared minus 2x plus 5x is plus 3x, and then minus 10. And you'll get the same thing if you use the area model. Okay, so now my question is, now we've done, this is a review. We are distributing, we're just multiplying. How would we get back to this? If I would just gave you this and I said, give me the two factors, x plus 5, x minus 2. How would you do that? So we're going to talk about that now. All right, so I'm going to give you a technique. And you need to know what I told you at the beginning. Ax squared plus bx plus c is the general form of a quadratic. So these are all quadratics. So you've got to name a, b, and c to be able to do this. All right, so a is 1, because there's a 1 right there. We just don't write it. B is 3, and c is negative 10. All right, so the first thing we want to do is put the product AC at the top, negative 10. And then we want to put the sum, which is going to be the middle term, 3. All right, what am I doing here? Well, I want you to think about what we did up here. I'm not going to talk about it. I'm just going to think about it. Why the 3 is the sum? Why is the 3 the sum? All right, so now you want to think of two numbers that go right here that are going to multiply to give us negative 10 and add to give us 3. So the only two things I know of that multiply to give us negative 10 is negative 2 times 5 or 2 times negative 5. But which one sum together, add, to give us positive 3? Well, that's going to be negative 2 and 5. That will add to be 3, multiply to be negative 10. So now we can write our factor as x minus 2, x plus 5. And that's our answer. But I would not stop there. I would multiply it out using FOIL or whatever method you like, and make sure it brings you back to where you started. Okay, x minus 2, x plus 5. And that's what we have up here. So I'm not going to show you again, but that's what we just checked. That's what we did up here. And generally what you want to do is you want to check as soon as you get your answer to make sure it brings you back to that. And then you know you're right. All right. So there's multiple ways you can draw this little box thing. Instead of having to draw the whole box like that, which is kind of tedious, you can just draw it like this, where this is the top box and these are these boxes and this is the bottom box, right? Without having to draw all the parts. You could do it like that. The other way, and a lot of people learned this in high school, is the X method. And so the AC product goes here and B goes down here, and you do the exact same thing. You find two numbers here and here that multiply to be AC and add to be B. All right, I'm going to keep using my boxes because I made them on my computer. So there they are. All right, so find A, B, and C. So pause the video and see how far you can get on this. All right, so hopefully you gave it a try. Remember, this is a 1 and this is a 1. So A is 1, B is 1, C is negative 20. Don't miss the negative there. So the product AC is negative 20, and the sum B is 1. All right, so what two things do you know of that multiply to be negative 20 and add to be 1? Well, it's probably going to be a 4 and a 5. So we've got negative 4 times 5, or we've got 4 times negative 5. Which one gives us a positive 1? And that is going to be the negative 4 and the 5. Okay, so that means that we get x minus 4, x plus 5. All right, so that's our answer. That is our factors. So we've got factor 1 is right here, x minus 4, and the other factor is this one here, 2 factors. Okay, factors mean things that multiply together, and remember there is a multiplication in between these. They're multiplied together. All right, so remember to go multiply this out. I'll just do a quick area model. And so we've got x minus 4 and x plus 5. And we get x squared minus 4x plus 5x minus 20. And that gives me x squared plus x minus 20. Is that what we started with? Yes, it is. So we're good. We got it right. All right. So let's try factoring this. So go ahead and get started. Pause the video and do as much as you can. All right, so hopefully you got a 1, a negative 5, and a 6. Okay, so the product AC is 6, and the sum B is negative 5. So what two numbers that do you know of that give you 6 when you multiply and negative 5 when you add? So 6 can be 1 times 6 or negative 1 times negative 6. That one adds to be 7, and this one adds to be negative 7 when we add them together. Negative 2 times negative 3 is going to give me positive 6. That's going to give us, add them together, and we're going to get negative 5. And then 2 times 3 is going to give me 5. So do any of those... So hopefully this isn't confusing. This is the multiply, and then when I add them instead, this is the number I get over here. So this is how I work it out in my own head. All right, so what do you think? What's going to be our numbers? So I've got negative 2 and negative 3. So those sum to be a negative 5, and they multiply to be 6. Make sure I didn't make any mistakes here. Okay, so we get x minus 2 and x minus 3. All right, so again, you should probably double check. So pause the video and double check on your own and see if you get the factor that we have up above, the thing that we're asked to factor right up above. All right, so hopefully you did that, and it does give us x squared minus 5x plus 6 when you multiply it out. All right, so can every trinomial be factored? Can every trinomial be factored? So let's try this one and see. So B is 3 and C is 7. Okay, so the product is 7 and the sum is 3. So can you think of anything? So two things that multiply to be 1 times 7, they add those together and you get 8. Negative 1 times negative 7, add those together and you get negative 8. There are no other factors of 7. There's nothing that would add together to be 3. So this is not factorable. So this is an example of using the quadratic formula, which we're not doing quite yet. All right, so that's not factorable, so you wouldn't be able to factor it. All right, so that is the end of this video. I will start by talking next time about trinomials or quadratics that have a number right here that is not 1. They're a little harder to factor, but I'll give you a technique to factor them. All right, thanks for watching.